Okay. Hi, everyone. My name is Cornelia Davis. I will tell you a little bit more about myself with the next slide. So I spent a lot of time, the last 15 years or so, working in the distributed system space. I was very fortunate to be able to live in the microservices world, really grow up in that world. And so I understand a little something about keeping these types of systems as resilient as possible. This is a slide that I've been using for a long time. It's a slide that Netflix showed. And what this shows you is it shows you the call tree to generate the Netflix homepage. So the Netflix homepage, in order to render that, you have to make roughly, actually more than 100 downstream requests. Now, if each one of those APIs, those downstream APIs, boasts 4 nines of availability, and we make the simplifying assumption that the network is reliable, which we know it's not, right? But even with that simplifying assumption, by the time I get to the Netflix homepage, I've lost 2 nines of availability. That's not very resilient. And so what happened during this era of microservices is we learned how to build systems that were more resilient than the infrastructure it was running on. You see where I'm going with this? Now, what we did during the microservices era is that we as developers learned a bunch of patterns that we can use to achieve that, to make our systems more resilient than the infrastructure that it's running on. These are a bunch of patterns that are on the inside cover of a book called Cloud Native Patterns that I happen to have written. So shameless plug there. But the point is that the developer was responsible for these patterns. The developer had to implement retries if something went wrong. They had to implement circuit breakers to protect in the case of too many retries. They had to implement event-driven systems. They had to implement resilient backing stores and so on. Now let's turn our attention to agents. So agents have a lot of different definitions, but I think we can all agree that this depicts one of the definitions of agents. We've got a loop, and it's making calls to LLMs, it's making calls to tools and other downstream services, it's reflecting on those things, deciding what, looping through again. If we go to the next level, we realize that those steps in the agentic loop are making external calls. So you see it's a distributed system. You see why I started with the distributed systems that we know a lot about already? So it's a distributed call to the LLM. It's a distributed call to an API. And it's a distributed call to more agents, right? We're hearing a lot about multi-agent systems. Now, layer over that all the types of things that can go wrong. Networks can go down. That's a fallacy that the network is reliable, right? It's flaky all the time. LLMs can be rate limited. APIs can go down. Downstream agents can be experiencing problems. And the agents themselves can crash. So these are all the types of problems. Now, looking at that lower right-hand corner where you see an agent calling another agent, well, here's a network of agents calling agents and eventually calling LLMs and downstream tools. It's starting to look a little bit like the Netflix diagram that I showed you, right? Except for one difference. It's another order of magnitude bigger because one of those nodes isn't calling one downstream service or 5 downstream services. They're doing it in a loop. And we know that these agents are sometimes looping 2, 3, 20, 100 times. So the scope of the problem here, where in Netflix we had 100 downstream requests, we might have 1,000 downstream requests that are needed to satisfy one agentic run, right? And so you layer out over all the things that could go wrong on that, and oh God, that scares the heck out of me, right? It is a crazy environment. So I want to introduce to you Temporal. How many folks have heard of Temporal? Okay, about, not counting my colleagues that are in the room, I would say maybe 15% of you or so. Temporal is a frustratingly well-kept secret. But what Temporal allows you to do is, remember I emphasized that during the microservices era, we figured out what the patterns were, but the developer was responsible for implementing those. What Temporal does is it takes responsibility for implementing those patterns on behalf of the developer. So rather than the developer having to implement retries, and I'm going to show you some code in just a minute, you get to program, the developer gets to program the happy path, and we handle those distributed systems failures for you at the back end. So it's like distributed systems logic for free. It comes in the form of a backing service, as well as an SDK that allows you to program in 7 different languages. So those are the ones that we support. The community has created SDKs in a number of other languages, as well as including hot off the presses Swift. So Apple worked on an SDK for that. Speaking of well-kept secret, I will tell you one of the punchlines here. How many of you use Snapchat? How many of your kids use Snapchat? Every snap goes through Temporal. Every Airbnb booking, every DoorDash order, every Taco Bell order goes through Temporal. Anybody using Codex? OpenAI's Codex runs on Temporal. So Temporal is widely used in mission-critical applications, but frustratingly well-kept secret. So here's what we're going to do. I'm going to show you this example in just a moment in a demo running. Good, we're doing good on time. It's a simple agentic loop. So what you see here is that we're making a call to the LLM. We're asking whether the LLM has made the decision on invoking a tool or not. If it doesn't invoke a tool, then we just loop again. If it invokes the tool, we invoke the tool, and then we loop again. So it's just an agentic loop. The reality is that in that box there, you've got your, let's say, your Python program that's implementing the agentic loop, or you might be using a framework like the OpenAI Agents SDK framework, and it's making these external calls. And when things go external of your application, that's when you don't have control anymore. What we're going to do with Temporal is notice that the application, the structure of the application isn't going to change. Now I've got this as a Temporal application. The actual agentic loop is implemented in what we call a workflow. So that doesn't mean predetermined. It's just a loop. It's just a loop that we've implemented, and it's just code. You'll see, it's just Python code. And then anytime we're doing external calls, we wrap those external calls in activities. And that gives you all, that's where all the distributed systems logic gets injected, is at that boundary. So with that, let me move over to the demo. Let me find it. Okay, here we go. So I'm going to go ahead and play this. So what you see here, it's a little, is there any way we can turn down the lights in the front for a moment? It's a little hard to read on the screen. So if not, I'll keep going, but if there is a way to do that, that would be great. This is up on YouTube, and so I'll go back to that diagram if you want to watch the video later. But what you see here is just plain old Python code. There's a while true at the top, so that's that loop that you saw. And then the first thing that we're going to see is we're going to see the LLM called. That's what's happening there. It's wrapped in an activity, and I'll show you what that activity looks like in a moment. Then we get back the response from the LLM. We check to see if we need to do a function call. Those function calls wrapped in an activity. And down at the bottom, you're going to see where those activity calls are. So here it shows you that we're making a couple of calls. So let me go ahead and speed this up a little bit. So now, even harder to read on the right-hand side, it's actually a pretty decent font, but I'm running the agent. What you see there is just the output of the agent. See the dotted lines? In between the dotted lines is one time through the loop. So sometimes, let me go back here a little bit and pause. Sometimes when we go through the loop, we're just communicating. Sometimes we're making tool calls. So you can see there, made a tool call. So now, this is what this looks like in Temporal. So this is our UI, and it shows you that I made calls to the LLM, that's where it says create, and I made calls to tools. So it's all working. So if we fast forward a little bit, this was the execution that we just saw. It took a lot of turns, But there was this one was an earlier one where it was a lot of turns. Sometimes the agents take a couple of turns, sometimes they take a lot of turns. So if we speed up here again a little, I want to show you, I'm running the agent again, and I'm going to do two things. The first thing that I'm going to do is I'm going to kill the network. So, I went too fast. So I'm going to kill the network. And what you see now, and let's see, it's going to keep going, is you'll see there that that in Temporal, it's showing you that it's having a problem. It's having a problem executing the LLM call because the LLM is inaccessible. After a while, I'm going to go back and I'm going to re-enable the network, and you'll see that in just a moment turn green, and it completes. Now, the next thing that I'm going to do, and final thing, Jen, I am almost done, is that I killed the process. I actually killed the agent process. I Control-C'd it. Not running anymore at all. The agent is gone. You can see here that there's a red bar. And now if I go to bring it back, I went over to the terminal and I restarted the agent. I restarted the Python process, and it just continued. That's what we mean by failure proof. So with that, I won't go into that. There was the instructions for the agent. The final thing that I just want to show you here is all of those resilient services don't live in your process. Remember, I killed the process.
Thanks very much for joining me.
They live in the backing service.
In the midst of
That's why when I brought the process back,
times,
I was failure proof. Wicked cool
of
technology.
America,
We're out there as well. Come
change,
find me.
move
We can show you more about it.
totalitarianism,
So thanks so much.
The horrific war in Gaza, the growth of